Today I want to talk to you about physical storage, how the information, data and information, or data and instructions, as we spoke about software, how they are recorded in the memory. Okay, computer memory store, that is the storage unit. Okay, when I say memory, it's a storage unit where you store and keep information, right? Information, data, and instruction. The computer's memory is a two-state storage. That means it has only two states. Okay, uh, either one or two. So it can't be having any other. Only two state. We will see more about that in a minute. This storage gets electricity from the computer to maintain its state. Now it has to stay in one state or another state. How it happens inside the computer in the memory is based because of the electricity. When you switch on the computer, the power is there in the computer, right? Using that power, these devices keep their state. When if they are kept at one state, it will stay at that state. If you are kept at the other state, it will stay at that other state. So the managing of the state actually happens using electricity. But what we are really interested in is it is two state. Okay, the two state can be off or on. We can consider them as off or on. One state is off, the other state is on. It does not have any other state. Okay, only these two. Either it can be on or it can be off, right? At the same time, one can't have both. Okay, one can only be either off or on. The off state is physically maintained at around 1.8 volts. That's the part I told you. Some electricity is used inside when from the computer to maintain this. So the off state is maintained at around 1.8 volts, not 0 volts, because 0 volts means no current. So that is physically not possible. So say they take as off, it's actually not off, but some very low voltage, 1.8. The on state is physically maintained around 5 volts. So that's a higher value. So 5 volts, around 5 volts will be on, around 1.8 volts will be off. So those are the two states. So rather than talking about that as 1.8 volts and 5 volts, we will just say off and on. Okay. So when you say off, you know it's 1.8 volts. When you say on, you know it's around 5 volts. So here's an example. Okay. So that is what I want to show you is in this graph, you have 0 voltage. No, this is the volts. Okay. 0 voltage, 1.8 and 5. Okay. So what I have tried to show here is around this area, there is not exactly always 1.8 because it's electricity, right? There can be ups and downs, some small surges going down or going up. But as long as the value is around this area, it will consider that as the off state. So it need not exactly be 1.8 always. So that it's around this area. That's why they leave this room blank. They don't go to this area. This is never kept. So when you maintain around 1.8, it will be around this area, and that will be considered as the off state. If it keeps an electricity, the voltage volt of around 5, somewhere here, up or down a little bit, plus or minus, that state is considered as the on. Okay, so we don't have to worry too much about only two state, whether it's at 5 or 5.1 or 4.9 or 4.3, it still considers as the on state. So that is one state. Anywhere in the region 1.8, it's considered as off state. So that's another state. So these are the only two states that you keep. So around 5 volts and around this. Okay. So think of this as the computer's language, that is on and off. And the language consists of only two letters. So you can think computer language with this storage has only two letters. One letter is off, the other letter is the on. Okay, so the software, that is instructions and data stored in memory, will look something like this. This is, let's say, off state, that's on state, maybe another on state, off state, on state, off state, on, off, on, something like this. Okay, that is uh, the some information, so some point of the memory. This is, let's assume this is the memory. Okay, in the memory, at this place the memory contains the off state, at this place the memory contains the on state. That is, if we talk about in volts, somewhere around 1.8 volts here, about around 5 volts here, around 5 volts here, around 1.8 volts here, around 5 volts, like that. So we will not go to volts. We will just say off, on, off, on. All the green ones are on, all the white ones are off. So wherever it has to keep off, it'll be keeping the off one. Wherever it has to keep on, it'll keep the on one. Let's see why this is needed. Okay, it cannot have anything else, as its language consists of only two alphabets, off and on. So its memory can only be a combination of these. You can't have any other thing coming out from nowhere. Okay, out of the blues. It will be off or on. So if it's continuing, it has to continue also like that, off, on, off, on, off. I don't know, whatever. That why? How do you decide whether it is off or on? We will discuss later. Okay, so don't worry about that. So the memory is stored like this. It cannot have anything else. Its language consists of only two alphabets, off and on. That is this. To understand this a little bit further, let's take English language. For example, as you know, English language has 26 alphabets, which means we are allowed to write English words only with those 26 letters. So any English word you write will be only using these letters. You can't use anything else. So the same rule applies to the computer language also. It has two letters, so everything it writes has to be within these two letters. That's why it's always like this. It can't have anything else. Okay, other things won't be allowed here because that language supports only two letters. If it is English, it supports 26 letters. You use the 26 letters to write your words. In computer language, you have only two letters, off and on. So you use that to write your whatever the words in the computer language. So when data and instructions are stored in the computer's memory, using these two letters only, all those words are formed up and written. So when you look at the memory will look like this: zeros, off and on and off and on and off, in a combination of these. Okay, this is just an example. Okay,